Hey guys, so today we're going to be looking at the nth term test, and I prepared for you 3 examples that represent the 3 types of series that you can see for this nth term test. So the first example represents the series in which the dominant term in the numerator is equally as dominant as the dominant term in the denominator. So let's rewrite this as the limit as n approaches infinity of n factorial over 2n factorial plus 1. And as I said, n factorial is equally as dominant as n factorial in the denominator. So what you do here is you divide the two, and your answer is going to be the constant, that is the fraction of the two dominant terms. So it's going to be 1/2 in this example, in this case. And what this means is that the sequence converges to 1/2, and the series actually diverges. And this may seem a little bit confusing, but this actually makes sense. And this is because if the sequence converges to a number that is not 0, then that means that at the nth term we keep adding a number that is significant. So if we keep adding a number that is significant, then that series, the sum of the series, keeps getting bigger and bigger, and it will keep getting bigger and bigger until it approaches infinity, which means that the series will diverge. However, the other case is if the sequence converges to 0, then that means that at the nth term we have a number that is so insignificant that it's considered 0. So at the nth term, we're adding numbers that are so small that they are considered 0. So the series will actually converge to a specific number. So let's look at the second example. This example represents when the dominant term in the numerator is actually more dominant than the dominant term in the denominator. So let's rewrite this. So the limit as n approaches infinity of n cubed over 3n squared plus 6. And as I said, n cubed is more dominant than n squared. In the race to infinity, n cubed is going to win. And so if the dominant term in the numerator is more dominant than the dominant term in the denominator, the limit as n approaches infinity is always going to be infinity, because the numerator is going to approach some very, very large number, while the denominator is also going to approach a large number, but it's going to be significantly smaller than the numerator. So a very large number over a relatively smaller number is going to be infinity. So that means that the sequence and the series will diverge. And we know this because at the nth term is going to be an infinitive value. And if we keep adding infinitive values to our series, then our series is going to approach infinity, and the series is going to diverge. Now let's look at the third example. This example represents when the numerator's dominant term is less dominant than the denominator's dominant term. So let's rewrite this. The limit as n approaches infinity of n over 2n squared plus 2. So here we have n, which is less dominant than n squared. So in the race to infinity, n squared is going to win. So what happens here is we have a relatively smaller value and a relatively very large value. So a relatively small value over a relatively large value is going to give us 0. So whenever we have the more dominant term in the denominator, the sequence is always going to approach 0. So the sequence converges to 0, and the series is actually always still going to converge, but we don't know to what. This test will never tell us what the series converges to. So 2 things to remember from this video. The limit as n approaches infinity of the sequence of the series tells us what the sequence will converge to if it does converge, and it also tells us if the sequence diverges. If the limit as n approaches infinity of the series is 0, then the series converges, but we do not know what to without doing another test. And if the limit as n approaches infinity of the series equals some number that is not 0, then the series diverges.